So today we're going to be doing linear relationships. So we're going to be talking about slope-intercept form and proportional relationships. So the TEKS we're going to be covering is 8.5i. I can write an equation in the form y equals mx plus b to model a linear relationship. 8.4c, I can use data from a table or graph to determine the rate of change or slope and y-intercept. 8.5f, I can distinguish between proportional and non-proportional situations. 8.5h, I can identify examples of proportional and non-proportional functions in situations. 8.5e, I can solve problems involving direct variation. So 8.5i and 8.4c are the same thing. In 8.4c, we're just kind of identifying like this is the slope, this is the y-intercept. 8.5i, we're taking it one step further and putting it in slope-intercept form. So if we know how to do 8.4c, it's going to take us like 5 more seconds to do 8.5i. 8.5f and 8.5h are both the same, talking about proportional and non-proportional relationships. And then 8.5e is direct variation. So let's go ahead and start with slope-intercept form. So slope-intercept form is y equals mx plus b. We actually don't even need to memorize this formula. If we look in the front of our booklet, we have slope-intercept form y equals mx plus b. So we don't even need to memorize this. We have it here in our formula chart. But we do need to know what m is and what b is. So m represents the slope, b represents the y-intercept. So we're going to go ahead and look at a couple examples. So for example, a line with a slope of 8 and a y-intercept of -10 would have an equation of 8x minus 10. So we wrote down this formula, and instead of writing m like we do in the formula, we replaced m with the slope, which was 8. And instead of writing b, we replaced it with -10. Remember, plus, when we add a negative number, that's the same as subtracting a number. So they just changed that to -10 to simplify it. Another example, an equation of y equals -3x plus 5 means that the slope is -3. So if we look, m is attached to x, so that's going to be our slope. Here, the -3 is attached to x, so we know that's our slope. And then b, the y-intercept is on its own, and -5 right here is on its own, so we know that this right here is the y-intercept, and it's a +5, so we know it's a +5 right here. So let's go ahead and do a couple examples writing the equation. So first we have to find the slope. So we can use our slope formula, y2 minus y1 over x2 minus x1. So we can find this coordinate, make it x1, y1, x2, y2, and then subtract them and plug them in here to find our slope. Or we can use the rise over run that we learned earlier. So rise over run equals. So we're going to start with our left point here. Our 2 points already picked for us, but if we didn't have those points picked for us, we would choose points that would cross right through the corners. We don't want to pick like this one where it's kind of going through the middle, this one right here where it's kind of going through the middle. We want to pick points that are passing right through the corners of my graph. So here is one, here's the other one. We're going to start with our left point and go to the right, just like when we read. So here's left, here's right. Starting from this point, we're going to do our rise first, since that's in our numerator. That's going to go, we're going to say, okay, to get to this point, I'm going to rise 1. So we're going to rise 1. Since we went up, it's positive. And then we're going to go to the right. We're going to run. We should always be going to the right when we go left to right. So it should always be positive for that one. So your run is 1, 2 units. So since we went up right here, going left to right, we're increasing. So I know that in the end, I should have a positive slope. So this does check out. So my slope right here, 1/2. I can't simplify that anymore, so it stays 1/2. Now let's find our y-intercept. Our y-intercept is where we cross our y-axis. So here is my x-axis, here is my y-axis. So this is the one that we're looking at. Where does it cross this line? Well, it intersects right here at this point. So this point right here is going to be B. So where it is 1, where y is 1. Now we're going to use this and plug them into our equation, y equals mx plus b. So we're actually going to write our equation, y equals, and instead of m, I'm going to plug in 1/2. So we have 1/2. And then we have x plus b, x plus, and then b, or my y-intercept, is going to be right here, 1. So this is what my equation should look like. Now let's go ahead and do an example with the table. So again, we could do y2 minus y1. We can make this x2, x1, y2, I'm sorry, x1, x2, y2, y1, y2. And then we can plug it into the formula right here. So if we wanted to x1, x2, this is the y column, so y1, y2. So if we wanted to plug it into that formula, because it's easy for us to just type in the formula into our calculator, we can do that, or we can do our change that we've been doing. So from 0 to 2, my change is plus 2, because we're increasing by 2. From -9 to -1, we're increasing, we're getting more positive, so I'm adding. And then we're going to have added 8. And if I wanted to check that to see if that was really adding 8, we would type into our calculator -9, what I started with, the change that I think happened, plus 8, and see if I end up with an end result of -1. And I do end up with -1. So I started off with -9. I think the change that happened was plus 8, and I ended up with -1. So here's -9. I think the change was plus 1. Yep, it was -1, so this checks out. So then we're going to write our change in y over our change in x. So our change in y right here, this is the y column, so it was 8 over my change in x was 2. So I'm going to think, can I simplify 8 over 2? If I'm not sure, 8 over 2, click Control Enter, and we have 4. So my slope is 4. Now we're going to find our y-intercept. Our y-intercept is where x is equal to 0. So let's see if I have an x equals 0 here. I do. When x equals 0, y is -9. So this -9 right here is my y-intercept. So we're going to go ahead and plug this into our formula. Y equals, instead of m, we're going to plug in our slope, 4, x, and then instead of plus b, we're going to put minus 9, because our slope was a negative number, so minus 9. Now, another thing, like I said, we want to do this example just so that way I can show you that if this method is easier for you, because you can use this method both on the graph and on your table, and that's the method that we want to be using because we want to do whatever is going to be easiest for us. So it says y2 minus y1, so here's y2, here's y1. So let's go ahead and do it on the side. y2 minus y1 over x2 minus x1. So y2 is -1, -1 minus y1 is -9, -9. So whenever we have whenever we're subtracting a negative, we put it in parentheses just so that way those two negatives aren't interacting and it doesn't look kind of confusing. And then we have x2 minus x1, so x2 is 2, x1 is 0, so 2 minus 0. So we can type this straight into our calculator. Control divide brings up my fraction. So we're going to type in -1 minus -9. And if you want to put that -9 in a parenthesis, you can. The calculator will know what you're talking about here if you didn't. And then for the denominator, 2 minus 0. And we click enter. We end up with 4. So even if we did our change right here and simplified 8 over 2 and got 4, or if we had used our formula that we had right here, we still would have ended up with 4. So now let's talk about proportional relationships. So a relationship is proportional if there is a constant rate of change between x and y. So for example, a graph that contains the origin and is linear. So let's go ahead and draw what that would look like. So here's going to be our graph. So it's going to cross through the origin and be linear. So it could be positive or negative, but either way it's going to be a straight line and it's going to cross through the origin. That would make it proportional. For it to not be proportional, the graph does not contain the origin or is not linear. So it could be one or the other. So let's go ahead and draw a graph. So for example, this one right here is not proportional because it doesn't cross through the origin. Let's see. This one right here, it crosses through the origin, but it's not a straight line, so it's not linear, so it's also not proportional. Now let's go ahead and look at a table. So here, let's go ahead and draw a table. The table has to have a constant ratio of y over x. So this is different from when we find our slope. So when we find our slope, we find just the change in y over the change in x. And when we're looking at proportionality, it could still have a slope. It's just going to be a more specific kind of relationship. So the y divided by x needs to be the same. So let's say we had a table and it was 1, 2, 2, 4, 3, 6. So let's check that. Y divided by x. So 2 divided by 1. 2 divided by 1 is equal to 2. Let's do the next one. 4 over 2. So y divided by x, 4 over 2 is 2. So it's the same number. And then 6 over 3, y divided by x, is still equal to 2. So this one is proportional because y divided by x is constant. These are all the same. So that's what makes it proportional. Versus a non-proportional table would not have the constant y divided by x. So let's go ahead and draw a table. So we have x, y. Let's say this is 1, 3, 2, 5, 3, 7. So here I'm increasing by 1 every time, and here I'm increasing by 2 every time, but let's see if it's proportional. So y divided by x, so 3 divided by 1 is equal to 3. 5 over 2, 5 divided by 2 is 2.5. So these are not the same. These are two different answers. This one gives me the results of 3 when I do y divided by x. This one gives me the result of 2.5, which are different. And then we have an equation. So an equation does not have an addition or subtraction when written in the form y, and is written in the form y equals kx, or y equals mx. So y equals mx right here, there is no b, it's missing. This one, however, has y equals mx plus b, so it has a b right there. So let's go ahead and write an example. So for example, y equals 1/2 x. I don't have plus or minus anything, there's no b, so this is good. But this one, y equals, let's say, 3x minus 2. Here it has the minus 2, so it has a b. My b is -2. Now let's go ahead and do the last example. So when we have proportional relationships, we have direct variation. So y varies directly with x. It's a proportional relationship where y equals kx. So we have an example. The amount of water an electric dishwasher uses to wash dishes varies directly with the number of loads of dishes. The dishwasher uses 32 gallons of water to wash 4 loads of dishes. How many gallons of water will the dishwasher use to wash 10 loads of dishes? So we actually have in our formula chart our direct variation formula. We have y equals kx, so we can use this formula to help us. So there are multiple ways to do it, but I think that this is probably the easiest way to remember. So y equals kx, well, I just want that constant of proportionality, so we're going to divide by x to get rid of it, divide by x to get rid of it. So we have k equals y over x, and we're going to be using this y over x when we set it up. So this is how I'm going to be plugging it in. So I have 32 gallons of water to wash 4 loads of dishes. So this is going to be my x value, and this is going to be the y value. So I'm going to write, instead of y, 32 gallons over, that's going to correspond to 4 loads of dishes. So remember, x is your input, so that's going to be the number of loads of dishes affects how many gallons it's going to take. So I have gallons over loads, so I'm going to fill this in with gallons over loads, and then I'll plug in the numbers in a second. So let's see what it's asking us. So this is the information it already gave us. Now let's plug in what it's asking us for. How many gallons of water will a dishwasher use to wash 10 loads of dishes? So 10, I'm going to plug that into the one where I have loads. Gallons is on the top, so it's not going to go there, but loads is on the bottom, so I can plug the 10 right there. And it says, how many gallons? So this is the x. This is what I'm looking for. The question mark, the x, whatever variable you want to plug in here to know that this is what you're looking for. So let's go ahead and cross multiply. So I have 32 gallons is 10 loads. 32 times 10 So 32 times 10, when we multiply that, we get 320. Equals 4x, because we're multiplying these, but since it's x, it's just 4x. Then I have to divide by what I multiplied these, I'm going to divide by 4. If I look here to solve this, I would still divide by 4 to get rid of it, because I want just x. So divide both sides by 4. 320 divided by 4, x is equal to 80. So I need 80 gallons in order to do 10 loads of dishes. Another thing that you could do, kind of logically, if you didn't know how to set this up, is, okay, you know 32 gallons for four loads, how much would each load be? So you would just do, in your calculator, 32 divided by 4. So each load is 8 gallons. Okay, well, you want 10 loads, so times 8, and they would get 80 gallons. But this way will always work. Depending on the question, it might be hard to change it to the amount of gallons per load if it's a different scenario. So this is the way that you can always set it up. Now y'all guys are responsible for completing linear relationships. Please use your notes that we just filled out together. So this linear relationships part is going to correspond right here to the writing equations part that we just filled out together. So you're going to identify, we have tables and graphs, we're going to identify the slope, identify the y-intercept, and then we're going to write that equation. And then we're going to translate it. So the slope is going to tell us how much they charge, and then the pickup fee. So we're going to be plugging in the one-time fee is going to be our y-intercept, the per mile, the multiple fee is going to be m, the slope. Remember, m is multiple. So is this situation proportional or not proportional? We can extend this to see, okay, well, does it cross through the origin? Is y divided by x the same for every single one of these? And then we have a proportional, non-proportional. We have a card sort that y'all guys are going to cut out. And then you can glue them in where they go or tape them in wherever you think that they go. So you're going to cut these out and put them in. If you absolutely do not want to cut, then you can just write the letter in it. And kind of here on this paper, write proportional, non-proportional, and then just staple this entire paper into it. So that way you have it where you practice identifying it. Remember, for word problems, something that I didn't mention, m, your slope, is the one that occurs multiple times. So I always remember multiple starts with m, so that's going to be the slope, because m represents the slope, just like our note said right here. M is a slope. And then your y-intercept is that one-time fee, that initial fee, the one-time I guess, number that comes out, that would be B, your y-intercept. So whether they take away money from you one time or whether you start off with a specific amount in the beginning, that's going to be B. So keep that in mind when you're looking there. So when you're finished, make sure that you have your entire booklet complete at this point, and then go ahead and start the quizzes.